The Ling-Temco-Vought A-7 Corsair II was a subsonic, carrier-capable attack aircraft developed for the United States Navy and later adopted by the U.S. Air Force. Built for accuracy, endurance, and reliability rather than speed, the A-7 emerged from the demanding operational lessons of the Vietnam War era. It was created to deliver heavy conventional ordnance with precision, day or night, in all weather, while operating from aircraft carriers or austere land bases. In an age increasingly focused on supersonic performance, the A-7 demonstrated that range, payload, and avionics sophistication could matter more than raw speed in modern air warfare. 2. Origin and development history. The A-7 Corsair II originated in the United States and was developed by Ling-Temco-Vought Ltd. The program began in 1963 under the U.S. Navy's VAL heavier than air attack lot requirement. The aircraft first flew on the 27th of September 1965. The A-7 was designed to replace the Douglas A-4 Skyhawk, which, while agile and proven, lacked range, payload capacity, and modern avionics for evolving strike missions. Rather than competing directly with supersonic fighters, the A-7 focused on delivering accurate weapons over long distances with reduced pilot workload. The U.S. Air Force later adopted a land-based version, the A-7D, to replace the A-1 Skyraider and complement the A-10 in the close air support role. 3. Design philosophy and airframe. The A-7's design philosophy emphasized precision strike, endurance, and survivability through systems reliability. The airframe was derived from the supersonic F-8 Crusader, but redesigned for subsonic performance with a shorter fuselage and thicker wing. The structure is primarily aluminum alloy, with steel used in high-stress areas. No composite materials or stealth coatings were employed. Aerodynamically, the straight tinlet design, high-mounted wing, and large control surfaces provided excellent low-speed handling essential for carrier operations. Visually, the A-7 is distinguished by its large chin-mounted air intake, high-set cockpit with excellent visibility, and robust landing gear, reflecting its role as a stable weapons delivery platform rather than a dogfighter. 4. Engine and propulsion system. Engine configuration varied by variant. Early Navy A-7A and A-7B models were powered by the Pratt & Whitney TF30P6 turbofan, producing approximately 11,350 pounds force, 50.5 kilonewtons of thrust. Later variants, including the A-7D USAF and A-7E US Navy, used the Allison TF-1A1, a license-built version of the Rolls-Royce Spey. The A-7 had no afterburner, reflecting its subsonic mission profile. The thrust-to-weight ratio was modest, but sufficient for carrying heavy payloads over long distances with good fuel efficiency. 5. Speed and flight performance. The A-7's maximum speed is approximately Mach 0.95, or about 1,120 kilometers per hour, 695 miles per hour at altitude. Cruise speed during strike missions typically ranged between 800 and 900 kilometers per hour. The service ceiling is approximately 42,000 feet, 12,800 meters. Rate of climb is around 15,000 feet per minute in lighter configurations. Maneuverability is stable and predictable rather than agile, optimized for weapons delivery accuracy rather than air combat. 6. Range, endurance and fuel. One of the A-7's defining strengths is its range. Combat radius is approximately 1,000 to 1,100 kilometers, depending on payload and mission profile. Ferry range exceeds 4,000 kilometers with external fuel tanks. Internal fuel capacity is approximately 5,500 kilograms. The aircraft is equipped with aerial refueling capability, significantly extending endurance for deep strike and loiter missions. External drop tanks were commonly used in both naval and Air Force operations. 7. Fuel consumption and operating cost. Precise fuel burn figures vary by engine and mission profile. But the turbofan-powered A-7 was notably more fuel efficient than earlier turbojet attack aircraft. Subsonic cruise and absence of afterburner reduced fuel consumption compared to supersonic fighters. Operating costs were lower than high-performance fighters of the era, though still substantial due to carrier suitability, avionics maintenance, and structural fatigue from low-level flight. Maintenance complexity was moderate, with high reliability rates reported in operational service. 8. Avionics and sensor systems. The A-7 was among the first attack aircraft to feature advanced integrated avionics. Early variants introduced a head-up display HUD, inertial navigation system, and digital weapons computer features uncommon at the time. Radar systems varied. The A-7D and A-7E were equipped with an APQ-116 and later an APQ-126 terrain following and navigation radars, mechanically scanned and optimized for ground attack. Electronic warfare systems included radar, warning receivers and countermeasures dispensers, significantly improving survivability. 9. Weapons and payload. All weapons were carried externally across 6 wing pylons and to fuselage stations, with a maximum payload of approximately 6,800 kilograms. Air-to-ground weapons included unguided bombs, cluster munitions, laser-guided bombs, AGM-45 Shrike, AGM-6 to Walleye, and later AGM-65 Maverick missiles. For self-defense, the A-7 could carry a 9 Sidewinder air-to-air missiles. An internal 20mm cannon was fitted single-barrel on Navy variants, and a twin-barrel M61 Vulcan on the A-7D. 10. Stealth and survivability. The A-7 has no stealth features. Radar cross-section and infrared signature are conventional for its era. Survivability relied on altitude control, electronic countermeasures, robust construction, and mission planning rather than signature. Reduction. This approach was effective against mid-20th century defenses, but limited against modern systems. 11. Real-world service and combat use. The A-7 served with the United States Navy, U.S. Air Force, and U.S. Air National Guard, as well as Greece, Portugal, and Thailand. It saw extensive combat in the Vietnam War, later operations over Lebanon, Grenada, and Libya in 1986. Operational evaluations consistently praised its bombing accuracy, reliability, and range. Pilots noted reduced workload compared to earlier attack aircraft, particularly in poor weather. 12. Cost, production, and global impact. Approximately 1,569 A-7 aircraft were produced. Unit costs varied by variant and production year, but was significantly lower than contemporary supersonic fighters. The A-7 influenced future strike aircraft by proving the value of advanced avionics and precision over speed. Its operational success shaped both U.S. Navy carrier aviation doctrine and Air Force close air support planning. 13. Strengths and weaknesses. The A-7 excels in range, payload, accuracy, and avionics integration. Its limitations include lack of speed, limited air combat capability, and vulnerability in high-threat air defense environments. Aging airframes ultimately led to its retirement. 14. Final verdict. The A-7 Corsair II represents a pragmatic chapter in aviation history and aircraft. Designed not for speed, but for effectiveness, its legacy lies in demonstrating that precision, endurance, and pilot-centric design can define battlefield success. Respected by allies and studied by rivals, the A-7 remains a benchmark for mission-focused military aviation.